I hope you are able to see the PPT, right? The screen. Okay, cool. So yeah, like in the last class, we have just deal about the course content, like what we will be covering in this entire course, and I have give you some guidelines regarding this attendance, viva, and assignments. Okay, and then let's start today's session. Today's session will be mostly introduction to like computers and programming languages. And Python is our main focus point. So let's see. I think you might already know most of the things, but still it's a kind of revision. Okay. So this is your today's topics. Basically introduction to computers and yeah, hardware and software components of computers and computer memory. That is how computer stores data through memory, primary memory, secondary memory, different types of memory, and yeah, basically how a program works, like how a program will execute. This compilation and interpretation process, and finally using Python. Okay, how to use Python. And yeah, hope I think in the last class I have told you how to install Python, and I hope you might have installed it. Yeah, if not, you try to install, and let's proceed. Okay, so basically, computers are like any device which process something, take some input and process it and provide some output. And how these computers do this processing based on the programs, like what are programs. Programs are nothing but set of instructions. Instructions are nothing but lines or statements, we can say. So based on these instructions, the, or these programs, computer will do certain jobs, and this set of instructions or programs are referred to as software, right? And this software tells what are the operations that are need to be performed by the computer, right? So so this is the software part. And yeah, the people who does this programs are called programmers, right? uh, in general context as well as in this developer concept or software developer, right? And so they basically create, design, create, and test. These are all are the jobs performed by the software developer. You might already know the software development life cycle, right? There are different software development life cycle models, like waterfall model, agile model, right? So you'll get to know about that's again an entire different subject. Yeah, people are still joining. Okay. And coming to the hardware, you already know like what are the all the different components of the computer, the physical components, or devices that make up a computer, right? Like the input components, output components, and the main central processing unit, the CPU, which we call as the brain of the computer. Uh, and right. Right. So the major components are the CPU. CPU is nothing but the processor, like the main microprocessor, which is the brain of the computer, and it has main memory, like main memory, which is nothing but RAM, random access memory, and the secondary storage devices like hard disk or SSD. And input output devices, obviously, input is nothing but keyboard, mouse, and output are like monitor, right? So basically, the software instructs the hardware, to perform different operations, and this software are nothing but programs, right? Which we write using any programming languages. And yeah, the central processing unit. This is the main, brain of the computer. Basically, it is the main thing which implements the software. Implementation means execution, like how the program will be executed and desired output will be generated. So this is the main part of the computer that actually runs the program, right? The most important thing, right? And the microprocessors are the main thing, like you might have seen the Intel processor, AMD processor. you know we have different generations, i5, i7. i7 is the latest one, and in that also we have different generations, like I think the 10th generation is the current one, right? AMD microprocessor, AMD Ryzen series, different microprocessors are available in the market. Coming to the main memory, uh, main memory is nothing but the primary memory. which the computer or the processor uses this main memory for so yeah, the main memory. Computer basically uses this main memory for for any operations. So basically, this main memory is nothing but random access memory. Uh, it is a volatile memory. Volatile means the memory is not permanent. This is just temporary. The main memory session is valid till the machine is on or the power on. Once the power is off, then the memory will be uh, erased. So basically this main memory is this is very fast, like this is temporary and this is very fast memory. So because the processor need to perform like millions of instructions per second, like, right? So this is very fast and temporary, right? And this is the like, yeah, I think we have covered everything regarding this point. And yeah, the basically the computer, the processor will copy the programs or any software from the secondary memory to the primary memory, because secondary memory is permanent, right? So the programs or any data will be copied from the secondary memory to the main memory, and the execution happens from the main memory, right? So this is the primary memory. Coming to the secondary storage devices, these are the additional memory, right? And yeah, coming to the primary memory, the RAM is like very limited compared to the secondary memory. Like in case of secondary memory, you will have like huge data. If you see any hard disk, it will be minimum of 1 TB, right? In TBs. But in case of main memory, it will be like in GBs only. Earlier, it used to be in MBs. I think nowadays, like 8 GB is more common. Main memory, 8 GB RAM is more common, but 16 GB is also available. 32 GB is also available, but they are very costly. In case of mobile phones itself, like earlier it used to be like 1 GB, but nowadays it is like around 3 GB, 4 GB, yeah, 8 GB, and expandable up to 12 GB. Nowadays, this expandable concept came like as based on the requirement, your memory can be expandable. That is a new concept in case of mobiles. And also we can expand, there will be like RAM slots in our computer. We can expand our uh, RAM memory, based on the availability of the RAM slots. By default, like in case of laptops, there will be like 4 GB RAM, 4 GB RAM, or like that. So we can expand it, like the capacity will be available, specified by the the manufacturer, like what is the maximum supported memory. So based on that, you can expand this. But obviously this is less compared to the secondary memory. In case of secondary memory, it will be like in TBs, at least 512 GB, right? So this can hold data for long periods of time, like mostly permanent. It's not volatile, it's not temporary. You can hold like data for long period of time. You can take backup, so your OS and everything will be present in this secondary storage. We can also call this as ROM. Yeah, RAM and ROM. RAM is the primary memory, ROM is the secondary memory, read only memory, right? And yeah, so basically the softwares or programs are stored here and loaded into the main memory when needed, right? Because the main memory is temporary, so the programs are loaded from the secondary memory to the main memory and executed, right? So this should be clear. And coming to the types of secondary memories, we have this hard disk. Disk drive is nothing but HDD, hard disk drive, which are like which contains the magnetic disks. So these are very sensitive compared to the SSD. SSD is nothing but solid state devices. So basically, there will be a circular disk, and data will be written onto it. The binary data, zeros and ones, are encoded into it based on the sending disk. Similarly, it is similar to our CD optical device, CD, but it is like packed, and we cannot see it. This is very sensitive. We need to handle it very carefully, otherwise the if any small crack, the entire disk will be corrupted. So This is a bit slow compared to the solid state devices, because obviously it is a mechanical device. Like the disk will be rotating in the hard disk drive. So, but it will provide like huge amount of capacity. Like it will be in TBs, like 1 to, we can expand this to many TBs. We can use multiple devices. And regarding this secondary memory, we have some concept called as RAID, which is nothing but redundant disk array. Like what happens is, when you write your data, in case of corporate, like corporate companies, they want backup. So what happens is, this hard disk will give you the backup. Like there will be like RAID 0, RAID 1, RAID 2, like till RAID 10. So based on the RAID number, the redundancy will be there. Like so go with the highest rate to get the more backup. Like even data in one section gets corrupted, it will be available in the other sections. So this concept is also something, again different concept, but something related to this storage devices. Right. This basically, hard disks have different sections, segments, and portions. Nothing but portions, different parts where memory data will be stored. Right. So this is something related to this hard disk HDD. And yeah, solid state devices are nothing but semiconductor devices, like the VLSI nano chips, semiconductor storage devices. So these are faster than the hard disk, because these are not mechanical devices. These are the uh, uh, what electronic devices, semiconductor devices. So this memory is very fast compared to the HDD, and obviously no moving parts, and stores data in binary format. Right, there are different like technologies in this SSD. Like these are very faster compared to HDD. Like nowadays laptops are coming with like 512 256 GB of SSD, or 512 GB of SSD, and they are very fast compared to HDD. If you have observed, like load your OS in SSD, and in a different laptop load it in the HDD, and you will feel the difference. The operating system loaded in the SSD will be like booted in seconds, like not in even 1 to 2 seconds. But in case of HDD, it will take like few minutes, like at least 2 to 3 minutes. So nowadays SSDs are getting its more popular than HDDs. It's always advisable to take SSD, because of this speed. It's advisable to take almost like HDD was the older technology compared to SSD. So it's advisable to take SSD. And they are obviously smaller in size compared to the HDD. HDD is compared to larger than SSD. SSDs are nothing but a simple pen drive. This flash memory, again, flash memory is nothing but same. SSDs only like our pen drives, right? And yeah, they are portable, obviously, and no physical disk, nothing but like not large. They are very small in size, like how the pen drive will be of or size of our pen cap. And yeah, optical devices. Earlier we used to have this CDs, compact disc, but nowadays I think almost no laptop is giving the CD option, CD drive. Earlier we used to have this VCD, DVD, different secondary storage devices, but they are again of limited capacity. Like CD will be of around 700 MB, 706 MB, something like that, and DVD will be around like 4.5 GB, something around like that. And yeah, very earlier we used to have this floppy drives. I think your generation might have not seen this, but in our childhood days we used to see those floppy disks, which contain very like few MBs of RAM, not even MBs, KBs, I guess. Yeah, something in KBs. Okay, so that's all about secondary storage devices. Basically, this is the where software resides, and when the machine is powered on, the software will be copied from the secondary storage to the primary memory, which is nothing but RAM, and the program execution happens right from the primary. This is all about memory. And coming to the IO devices, input and output, we already know, like Input is nothing but which takes data, something as collects data from either from people, the person who is operating the computer, or again from different devices, like uh, you know based on some sensors, like for example remote sensing, weather sensor. So again, in case of we use computers in different domains, like weather, we have different uses. So any sensor can also provide you the input. And so basically the input device is nothing but the component that collects some data. And yeah, keyboard, mouse, touch screen, scanner. Yeah, scanner is again a device. Camera, your DSLR and all. So these are the example of input devices. And yeah, even disk drives, HDDs can also be considered as input device, because the program is coming from the HDD, right? So the main memory, the program is getting loaded into the main memory. So even you can consider this HDD is also an input device. And output devices, where we can see the data, or the computer provides the output to the people, or again any devices. So this can be any format: text, image, audio, video. With stream is nothing but video. Okay, different output formats. And devices are like monitor, or any TV, printer, right? and and also, yeah, this disk drives and USB drives can also be considered as output device, because we can also save the data is sent to them to be saved, right? And coming to the main thing, till now we have dealt about this hardware, right? Like memory and input output devices, these are mostly like hardware related things, hardware components. Now coming to the software components. Uh, so yeah, this hardware part of the computer is being executed by the software components. So basically, yeah, basically there are two types of software: application software and system software. So what is the basic difference is nothing but the system software is nothing but the operating system. Operating system is called a system, or the main kernel. The kernel is the core of the operating system. So the system software is nothing but the kernels of the softwares which are coming with the operating system, the default softwares, right? And the application softwares are nothing but the third-party software. We can simply consider them as third-party software, like browser, different browser, Chrome browser, Microsoft Office. Like, see the and day-to-day activities, we use this application software, different types of application software. At the end of the day, both the softwares perform operations on the hardware only, but like this system software is more powerful than the application software. The application software are like they are in the user level, but system software runs in the kernel level or OS level. So that is the basic difference between application software and system software. We can write both. Like we can write most of the software developers will write application softwares, which have some use application. But system softwares are like drivers. In laptops, we'll have different drivers, like audio drivers, input drivers. So those are the system softwares. Yeah, for day-to-day everyday tasks, we use application softwares like this word processing, games, web browsers, everything are considered as application softwares. Simply the third-party softwares which we install in our day-to-day lives, right? And the system softwares are nothing but the softwares that come inbuilt, like the Paint, MS Paint. We can consider that as it's an application software, obviously, but that comes along with the OS, right? So like that, some drivers are part of the system software. Yeah, the programs that control and manage basic operations of computer, basically this operating system, this controls operations of hardware components. And utility program, it has some utility, right? They perform some specific task to enhance computer operation or safeguard data. Av is antivirus. Av is nothing but antivirus is considered as a system software, though it is third party, like, but still it operates at system level, right? Yeah, in software development tools, yeah, this IDE, integrated development environment, this Visual Studio, and all these are again system software, because they they used to create, modify, and test different software programs. So they are also considered as system software. So simple, something related to operating system, right? And development part is dealt with the system software, and the day-to-day activities like web browsers and any third-party softwares like Office and all, we can consider them as application softwares. This is the basic difference. And yeah, mostly these are concepts will be important for your viva and like interviews. Mostly they will be used. And finally, how computer stores data, obviously in memory, secondary memory, to be specific, because primary memory is volatile. Yeah, and in the format, in binary format. Binary format is like bi means two, either zero or one. So it's on. These are called bits. All data is computed stored in binary sequences, which are called as bits, zeros and ones. And yeah, byte is nothing but 8 bits is called a byte, right? Simply, bit is nothing but either zero or one. Uh, is called bit, and byte is nothing but combination of 8 bits is called byte, and combination of 4 bits is called nibble, which is not much important, but just for your knowledge. And yeah, basically byte is the enough memory required to store a number, letter or a number. Like for example, any character A, it will take 1 byte, which is nothing but 8 bits, and they will be stored in either ASCII format or UTF format. That will be in, we will see in the coming slides. Okay. So the bit is the basic component. Simple, take an example of switch. Either it can be in on state or off state. On is nothing but one, off is nothing but zero. So basically, this, like we said, electronics deals with binary zeros and ones. So everything, this transistors and all, transistor is nothing but a switch. The application of transistor as switch is nothing but this processor or this memory, everything are electronic components. And yeah, they will be using these transistors, FET, we can say MOSFET, CMOSFET. There are different types of transistors. So like this transistor stores only either this transistor acts as a switch, so that either it can be in on state or off state. There are again millions of transistors, millions and billions of transistors. So so based on these zeros and ones, so this computer works basically. And yeah, the ANOF patterns in the byte represents data stored in a byte, right? Yeah, positive charge and negative charge. Positive charge is nothing but one, and negative charging is nothing but zero or on off, right? I think that's it. Coming to yeah, storing numbers. Yeah, like we see, bit represents two values, either zero or one, and computer uses binary numbering system. I think you might know this binary numbering system already, but still, like for example, value is like 100, 1 and 3 zeros. So the value is 8. How we know? Because based on the position, the extreme left, we can say it as LSB, least significant bit, most significant bit. The extreme left thing uh, will be of zero value, and next to it will be of value 2, and next it will be 4, and next it will be 8, like 2 power n minus 1 here, like j, 2 power j minus 1, where j is the position of the bit. Okay, so the value of the value of that position will be uh, obtained using this formula, 2 power n minus 1 or j minus 1, where j is the position of that bit, right? So obviously, in case of 1 byte, byte means again 8 bits. So 2 power 8, it will be 256, right? So the values will be varying from 0 to 255. So 0 is when all 8 bits of that byte are off, is called 0, and 255 is when all the 8 bits are on, 1111, like 8 ones, it will be like 255. Again, to store large numbers, we use several bytes. So byte is the basic element of storing numbers and letters. Like you will have different data types, like integer data type, short int, long int. Like we will see that in the next class, variables and data types. So there we will see like one character will take 1 byte, one integer will take like 2 bytes. Again, there are different types of integers like short int, long int, right? Double int, long double int. So based on the type of the data type, the memory will be allocated for each variable or for the data type. So that's why the basics. So obviously the data in computers will be stored in binary format. And yeah, even the characters will be converted to the numeric. Like for example, the ASCII value of a will be like, again, small a and capital A. For small a it will be uh, from 65, I guess, and capital A, no, sorry, small a it is 97, and capital A it will be like 65. So the equivalent number of the character. So I think you might already know this ASCII chart. If you simply search ASCII, you will be getting. I hope you are able to see. ASCII is nothing but American Standard Code for information interchange, like the American Standard, uh, basically, which denotes all the characters and numbers. If you see some ASCII table, oh, this is clear. Yeah, you can simply Google it. It's maybe, I'm not sure whether it's clear for you or not. See, so here, like the decimal is like the normal numbers which we read in our day-to-day life, and hex values, hexadecimal is again different format, uh, similar to this binary format. In case of hexadecimal format, the numbers will be from 0 to 9 and a to e. Again, it will be continued e and f, and then again 1 0 1 2, again a to f, like that. So these are the characters, like special characters and all. So if you see capital A starting from 65. 65 is the decimal number, right? Whereas hexadecimal value is 41, right? Basically, the value of each position will be, yeah, any issue? Okay, the value of each position will be 16. Like in case of binary, we have seen like 2 power n minus 1, whereas in case of hexadecimal, it will be 2 power 16 minus 1. Sorry, 16 power n minus 1 or j minus 1. So 16 power 0, 16 power 1. So basically 16 fours are 64 plus 1, 65, like that, simply conversion. 65 is the decimal value of capital A, and this is very much important, like for any developer, like they should know this, because they will be using this based on the application. And for small a, it will be like from small 61, uh, 61 hex and 97 in decimals, right? And numbers, if you see, numbers are starting from 31 in hex and 49, so 48. So the basic ASCII table, you go through this will be available in internet. You can simply search it. So let's continue with the class. I think some noise is coming. Okay. Yeah, the same thing, like we have seen this ASCII scheme. So in case of ASCII, we have seen all this 128 characters, but nowadays this Unicode format is the latest standard. Again, this ASCII is subset of Unicode. Nothing but this ASCII characters are also present in Unicode, and uh, basically this Unicode or UTF, we have different formats like UTF-8, UTF-16, UTF-256, like that. uh, these are basically used for representing the all the characters of all the languages, like not only in English, like we have Chinese, we have like Telugu, Hindi, we have different languages, right? So in computer, like every language need to be supported. So for that, every alphabet is assigned with some unicode value. So that is again a different scheme. So ASCII is for basic English and numericals, and Unicode scheming is again a standard. So this is again, the latest standard, which is also compatible with ASCII. And yeah, this can represent all the languages in the world, all the characters of all the languages in the world. So basically these formats are important, right? And okay, I'm presenting this right. Advanced number, yeah, to store negative numbers, we will use something called encoding schemes, binary numbering and encoding schemes. And like for example, in case of negative numbers, we use this two's complement. Two's complement is, I think you might already know, but still, it's simple. It's like we need to add one to one's complement. Now the question is, what is one's complement? One's complement is nothing but you simply replace one with zero and zero with one in any byte. So for example, like 1 triple 0 is your value. So simply you give 0 triple 1 and add one to it. So that will be your two's complement. And yeah, two's complement is used to represent the negative numbers in computer. And the real numbers are nothing but decimals, like floating point values. They are used using this floating point notation, like dot notation. Okay. Yeah, and other data types like let's say images. In images, we have this pixels, right? Again, each pixel is nothing but a each pixel is nothing but again a byte with some some values. So basically we have again different color combinations. So each color, like for example, red is RGB values. So red will have some unicode value. Each color, each pixel will have different unicode values. And so this pixel will store those binary numbers. Some issue with the internet or what? Okay. So yeah, the data nowadays it is storing in digital format, which is again nothing but binary format only. So let's take example as digital images, and which uses pixels. Pixels are again binary numbers representing the particular pixel color. Okay, and in case of music also, uh, in music we have this samples. We have samples, and each sample is stored in binary format. Okay, these are just different data types or data formats, you can say. Yeah, and now how a program works. So basically this programs can okay, let's see how this cpu is nothing but processor. This is designed to perform simple operations or different operations based on the data. So basically it will read the data, and yeah, so the basic operations will be like addition, subtraction, multiplication, and division. These are the mathematical operations. And these are only performed at the processor level. So every whatever the operation you do, that will be finally converted into these simple operations like addition, subtraction, multiplying, division. Okay. So and understanding these instructions written in machine language is like binary language, is what understand by the computer, right? So each brand of CPU has its own instruction set. Like Intel has its own instruction set, AMD has its own instruction set, right? So along with the CPU specifications, they will give you the instruction sets, right? So that's why in case of softwares, when you compile, you will compile based on your processor architecture. Like you will use different libraries and different you know yeah, different libraries for different CPUs. And I think let me take attendance in between. Like I said, I'll take attendance in between. Okay. So yeah, where are we? So this is the most important topic of this entire class. So how a program works. Till now we have seen just the basics like input, output, memory, you know. But the processor, how the processor executes a program or instruction, that is the main thing. So basically, any operation is converted into this basic operations like uh, reading data, adding, subtracting, multiplying, dividing. Okay, so and these instructions are converted into machine language. And yeah, like I said, each brand of processor will provide its own instruction set, and to carry out this meaningful calculations, CPU must perform many operations, right? Let us see those in detail. So like we have already seen, the program will be copied from the secondary memory to main memory, which is nothing but RAM. Every time the CPU executes the program. And yeah, the CPU executes any program in a cyclic process. So what are the main three parts of the cycle? These three parts, like fetch, decode, and execute. Fetch is nothing but read the instruction from the memory of the CPU. So basically read operation, and fetch is nothing but read operation. And decode is nothing but it performs the operation specified by the instruction. So that is the execution operation. To understand that operation, the CPU decodes the instruction that it fetch. Okay, so what is that operation? Whether it is add. So there is something called as mnemonics uh, in assembly language. So add, mul, sub. So these are called the mnemonics. So the CPU performs decode of the fetched instruction to understand or determine which operation it's need to perform. So basically, decoding is understanding, fetching is reading the instruction, decoding is understanding the instruction, and execution is performing the operation based on the decode, right? And so this is the pictorial representation. So this is the main memory, RAM, if you can see, and it will be the op codes or operation codes are available in binary format. And so CPU basically uh, fetch the instruction. Basically there is something called as program counter register is available in processor, and that will the counter holds the address of the next instruction to be executed, right? And that will be fetched and decoded. The decoded operation will be performed to understand what type of operation that it needs to perform. And finally it executes the instruction. So this is the program life cycle of the processor. So fetch, decode, execute. Yeah, but this machine language is nothing but binary language, zeros and ones. Uh, but people cannot write in machine language, right? So this assembly language is near to this machine language, which people can easily write. Not easily, but they can write compared to machine language. So this assembly language is also having lot of scope in case of right. So basically, we have seen this how this program executes. Just we have like 10 more slides. Yeah, we will close in 10 minutes. Don't worry. Okay, so this is the basic life cycle of this instruction cycle. We can say how an instruction is fetched, decoded, and executed by the processor. And yeah, assembly language is very much important. I was talking about the importance of assembly language in case of cyber security. If you know this assembly language, like you can do wonders. Like you can find vulnerabilities, you can write exploits. In cyber security there is a lot of scope, and in case of PLSA also, like for electronics guys, it is like much more useful. And not only for electronics guys, even for computer science guys also, like if you learn this assembly language, you can do wonders. Obviously it is having a lot of potential and lot of scope, right? So if you are interested, if you like it, if you have any chance. So because nowadays in case of cyber security, if you see any exploit, like most of them will be shell codes. There is something called as shell code. You will be knowing this in your cyber security classes. So just I am just telling the importance of assembly language. Okay. And yeah, the assembler basically assembler translate the assembly language into the machine language. Machine language is nothing but binary language for execution by the CPU. We have different assemblers like MASM, NASM, YASM, FASM, different assemblers like macro assembler by different companies. Okay, so different assemblers are there for converting your assembly language code or shell code to this machine language code. Okay. And yeah, low level languages, this assembly language is a low level language close to machine language. Okay, and high level languages are nothing but the advanced languages, like the Python, Java, okay, Go, C++, C sharp. These are all the high level languages. These helps the software developers, it makes the life easy of the software developers. You can easily write. It's like, compared to this assembly language or machine language, so no need to know how CPU works and all. You can write large number of instructions. Okay, but it's important to know how CPU works. Okay, and yeah, we can create powerful and complex tools or programs. And simply, so in tomorrow's class we will, in the next class we will see in detail, like what are keywords, operators, statements. Okay, simply keywords are nothing but like, some, for example, if is a keyword, if statement, which is a conditional statement, right? While is a loop. For these are all the keywords. So these are predefined words used by the program in high level languages, right? So import, include, these are all the keywords. Each keyword has some specific meaning. Okay, and operators are nothing but the basic operators, mathematical operators like plus, minus, symbols, all the symbols you can say, into, star, divided by. These are the operators. Operators perform operations on operands. Data is nothing but operand. And syntax is nothing but set of rules or protocols to be followed for writing a program, right? And statement is nothing but a simple instruction or line in high level language. So these are just few words. Okay, yeah, coming to the most important part, compiler and interpreter. So basically what this compilers do, compilers write this, compiles is nothing but conversion or translation. The programs written in high level languages, to translated to or converted into machine language. So basically this compiler do this translation or conversion from high level language to the machine level language or binary language, right? So how this compiler do this, again, you will have separate subject called compiler design, how you design a compiler, how it converts your, high level program into separate machine language. uh, okay, but this compiler, what it will do, it will do the entire program in one time activity, whereas interpreter does in line by line. So that is the main difference between compiler and interpreter. So the compiler translate the high level whole program into the machine level language, whereas if you see interpreter, this translate, executes instructions. So the difference is programs and instructions here. uh, Program, in case of compiler it's the entire program, complete program. In case of interpreter it is simply the instructions, like instructions are lines of the program, line by line. Okay, so the Python, the in Python we use this interpreter. Basically the Python is an interpreter language. So this is the main thing, the main, like, the first question asked by any interviewer or any, Viva person is whether the Python is a compiled language or interpreter language. So you must, say this Python is an interpreter language. Okay. Otherwise, if you, do this entire course and if you don't know what is Python, whether it's a compiled language or interpreter language, then it's like very awkward. Okay. So remember this. This is the main thing. Python is an interpreter language. Okay, and which means it executes or it translates one instruction at a time, right? Interprets nothing but conversion, translation. Okay, from high level to machine level. Okay, and yeah, source code is nothing but the program which you write, the program written by the programmer. And the syntax error, yeah, this compiler will check for syntax error, obviously. So prevents code from being translated. If any error, you'll get an error, trace back error. You can simply, check it. We will see that in error handling part, not a big deal. And yeah, this is simple and example or pictorial representation of how compiler or interpreter works. High level program like print hello world or something, and interpreter will convert into the machine binary, and which is executed by the program. And so basically interpreter translate instruction is nothing but single statement or line, whereas compiler translate an entire program. Okay, that's the only difference, and this process is repeated for every instruction. So yeah, for using Python, Python must be installed like from the Python website. 3.11 is the latest version. You can simply download and install it. Next, net install, and don't forget to add the path part which I mentioned in the last class. And yeah, Python interpreter can be used in two modes: interactive mode and script mode. I have already shown you the interactive mode is nothing but the command prompt, or this black screen or white screen which asks for line by line, which is nothing but interactive mode. Script mode is nothing but your program. You can save your program in .py file, and you can simply execute python.file name. That is a script mode. Okay. Yeah, the same thing. Interactive mode, basically it will ask for line to line, and script mode you can execute. I'll show you the difference. Okay, no, don't worry. Yeah, so you can write the Python file and save it as python dot something file name dot py, and you can simply execute Python and file name, right? So, an idle environment, idle comes integrated development program environment for Python. It comes by default with Python if you install. This is the basic development environment for Python, but you can also use visual code, okay, PyCharm. You can use different Python environments, okay. And yeah, the basics thing is like we have seen what is hardware components, software components, memory, instruction cycle, fetch, decode, execute instruction cycle, this compiler and interpreter path, and installing Python and interpreter modes we have already seen in this last class. So I think that's it for the day. It's already 9. If you have any doubts, you can ask me in the chat box. And yeah, meanwhile, if you want this PPT, yeah. So see, this is the basic command prompt. So if you simply type Python, so the whatever the mode available, so this is the interactive mode, right, or interpreter mode, interactive mode. So simply you can write your instructions like print hi. Oh, sorry, this brackets is missing. In Python 2, you can simply type this. I'll clear the screen. Yeah, I am simply going Python. Space is not there here. Codes is also required. Yeah, so this is the interpreter mode or interactive mode. So if you simply exit this, so you can execute any program using this Python and some file, any Python program.py. This is nothing but a script mode. This is the only basic. Okay, PPT I'll share here only in group. I'll just upload it and share it to you. Stop sharing my screen.